All right, friends and neighbors, welcome back to another networking video. Friends and neighbors, we face dark times indeed. It's come to my attention that many of you are not doing your static routing correctly. Many of you, and you know who you are, have chosen the incorrect use of the next hop. So in this video, we're going to be going through a static routing problem. I'm probably going to actually do two of them. One will include multi-layer switches, but let's get to the topology right now. So here we are. Here's our topology. I'm actually going to do this for you, but I'll point out a couple of its features. We have four networks: the 1net, the 2net, the 3net, and the 4net. These are /24s, so Class C networks. And so if you take a look at my routers, I've got 1.254, 2.253, 2.254, 3.253, 3.254, and 4.253. I've got int f0/0, f0/1, 00, 01, 00, and 0/1. You'll notice that I use a convention. So this is a numbering convention and an interface convention. I've also got for you here the default routing table. So this topology, up to this point, has already been built. So we have to finish the configuration. So the minute I give these interfaces an IP address and bring them up, and they have link, we are going to be able to use, or we'll be able to see that they have a default routing table. So each of them has two networks in their default routing table. And we're going to use the IP route statement to solve the connectivity problem. So without further ado, let's go to Packet Tracer and see how this whole thing works. And I'll remind you that while Packet Tracer isn't perfect, it does a really good job of showing you what you would actually do on an actual router or switch. Now in this video there will be no VLANs. Everybody's in VLAN 1, the default well, because we're not adding VLANs, so everybody's going to be in the default. But that'll be time for the next section of the video, or maybe the next video. All right, so here we go. And here is our topology in Packet Tracer. And so we're just going to do some tests here. I'm going to set up this particular host. And so the IP address will be, 192.168.1.1. We've got a default mask, and then the global settings, really the only one that I want is the gateway. And this is exactly what I would do on a host, right? And so we can see that the router interfaces are all up. So this is exactly the topology we just saw in the slide. So let's go take a look at command prompt. And I'm just going to try to ping my gateway. Now this should work because the gateway's been configured. They're on the same network. There's no real hard spot here. 1.254. Yeah, I think we're out of luck on as far as blowing it up goes. But we have a successful ping. Now we'll use the simulation tool here when we need to, because we're going to see where things fail. So I'm going to try 2.253. It's the next step along the way, right? That's this interface. So I just got to this one. We're just going to try the next one. And that one works too, because when I go to send this, it's off of my network. I go to my default gateway. My default gateway happens to know where the 2net is and where that address is specifically, because it knows how to get to the 2net, right? It's in the routing table, but also it owns that particular address. All right, let's try 2.254, which is just the next address over. Oh no, this doesn't work. Now, how do we solve this one? Or where is it actually breaking? Now the easy thing to assume is that the host couldn't get there. But we'll find out that's not exactly true. So we're going to open up our simulation here. And we don't actually care about the packets at this point. We just want to see where they die. And we're going to edit the filters here so that we don't care about all of the extraneous stuff. So we're going to get rid of CDP, DTP, STP. And I think that'll do it. Yeah. All right. So now I'm going to go ahead and do the ping again. We can see that it timed out. And we're going to go again. So it's queued up. And we're just going to march through. It goes, oh, so it actually goes out. Now this is, we'll see what the actual protocol is here. This is the ICMP echo request going out. So it gets to the router. The router says, where are you going? I'm going to the 2net. I know where that is. Let me see if I can find that destination. I know where 2.254 is. Now, if we looked at the router, I can do a show IP ARP on the router, and the router has already communicated with that address, probably because of my last ping. So it knows how to build a frame for this destination. And so now it gets all the way there. And that's where it dies. So we can see another attempt. So what's happening? Well, if we look at this particular packet, and hopefully you can see this, right? The source IP address is from 1.1. That's this node over here. Now that makes sense, and it's going to 2.254. Okay. What's the big deal? Well, we go back to real time here. The problem is, of course, on this router right here. This router does not know how to get back to the 1net. Now, I'm going to solve this problem, and the way that we would solve this problem is with the following command. I would say IP route 192.168.1.0, the mask, followed by the forwarding router's IP address. Now, the rule with the forwarding router IP is that it must be somebody that's not you, but somebody that you can touch. So this would be 192.168.2.253. Why is it 253? Because that's not me. We already know that router 4 doesn't know how to get there. But it has to be somebody I can touch. 2.253 can be touched by router number 4. And so that is what the command will actually look like, right there. Now we're not going to do that. We're going to address another problem that came up. And this is why we decided to do this video today instead of more SIP stuff. If I want to get all the way over here to the 3net or the 4net from the perspective of router 3, this one all way over here, what I could do is default route. And a default route on a router number 1, or router 3 in this case, would look like this. IP route 0.0.0.0, 0.0.0.0. Now, who would be the forwarding route for this particular entry? Well, this router has control over a stub network. There's really only one way off of this network through this router. To get to the rest of the topology, there's only one way, and that is through router number 4. Some of you have been saying that it's okay to forward traffic to this destination all the way over here. So what I've been seeing is the following. Well, I'll write down the correct one first, and then I'll write down what folks are doing. 192.168, 2.254. So from the perspective of router 3, this would be the correct default route. What some of you are doing, and you know who you are, is this. IP route 192.168. Whoops. We're doing default route 0.0.0.0, 0.0.0.0. And the rationale is I want to get to the 3net, so I'll send it to somebody on the 3net. So let's try 3.253 or 3.254. It doesn't really matter. because the result is the same. Whoops, 3.253, right? It stands to reason. I'm trying to get to the 3net, so I might as well send it to a router on the 3net. Let's see if that works. I'm going to go ahead and do that. If I spell it right. 000. And then 192.168.3.253. Let's see if that works. Now I'll show you the routing table. Show IP route. Now take a look here. We can see that I know about the 2 and the 3net. I've added this default route up here. It doesn't look like it appeared in the routing table. Huh, I wonder why that is. Well, let's try the other one. Let's try the other address on that particular network. So I'm going to also add 3.254. And we'll take a look at the routing table again. Huh. Why would the router not even put the routing table entry in there? And the answer is you don't know how to get to the 3net. This is like saying, I don't know how to get to the 3net, so I'll ask somebody on the 3net. Okay, cool. How do I get to that person on the 3net? I don't know. I'll take a look at my routing table and I'll just send it to somebody on the 3net. It doesn't make any sense. It doesn't work. The only way that this comes alive is if I tell myself how to get to the 3net. And so the way that I might do that is this. IP route 192.168.3.0, 255, 255, 255.0. And how would I get to the 3net? It can't be somebody on the 3net because I don't know how to get to the 3net. So it has to be somebody that's not me, because we already know I don't know. So it has to be, there's only one choice, and that is this interface right here. 192.168.2.254. Again, somebody that is not me, but somebody that I can touch. So let me make that note over here too. Forwarding router. Not me. Well, we'll do that. We'll do this. 1, it's not me. 2, someone I can touch. Meaning that you know the network already. So since I already know the 2net here, right, I can point to somebody on the 2net. So let's see what happens when we do that. Config T, I'm going to say IP route 192.168.3, whoops, 3.0. It's live, everybody. 255, 255, 255.0. How do I get there? 192.168.2.254. Now let's take a look at our routing table. And all of a sudden, those static routes pop up. So this is actually still very, very wrong, because what this does is a recursive lookup through the routing table. If you use this, and we'll actually get rid of one, we'll clean it up a little bit. So this was one of the entries. We'll just say no IP route. We'll get rid of that one. No IP route. So we don't have two default routes. Okay? So here what we have is a default route that's pointing all the way over here to 3.253. Now this is still wrong. Even though it came up, right? Even though it's there, it's still not the correct address to use for a default route. Why? Because you say to yourself, oh, I'm going to try to go to somebody on the 4net. Oh, here's my default route. To get to the 4net, I have to go to 3.253. Oh, how do I get to 3.253? I have to look that up in the routing table too. This is as opposed to simply pointing your default route at 2.254. Because if you do that, you already know that the 2net is directly connected. And so it's a simple ARP exchange. And so it is sort of one step sooner, and you already know, you already have knowledge of the directly connected routes. Now you could argue, well, you had to look it up that you were directly connected, but it doesn't really matter because you can't get to the 3net as a default route without this other route to get to the 3net, if you follow me. Okay. Now, obviously, this still doesn't work because we're just working on one router. But that is the issue. That is the thing that has arisen this week. And the only reason that you might have success with this is because you've just stuck routes all over the place. I'm going to show you we're going to do the static routes, and then I'll replace the static routes with a default route. Okay? So let's get rid of the default routes. Let's see, what do we still got in there? We still got 253 in there. So we'll get rid of that one. Show IP route. Okay, so the only networks that I have are the 1, the 2, and the 3. And so we might update this and say now we have a static route for 192.168.3.0. Okay. Now, we didn't solve the problem that we had earlier, which was that I needed to get to the 1net. So I'm going to do that one right now too. Show IP route. Whoops. Let's do config T first. IP route. 192, what's the network that we're trying to get to? Well, I did not know how to get to the 1net. Jeez. .0. Now, how do I get to the 1net? Well, I wrote down here that I get to it from 2.253. Again, not me, but somebody that I can touch. So 2.253. And by touch, I mean that you could ARP for that node. It's on the same network that you are. 2.253. All right, so if we do a show IP route here, we have this new static route. So what I'm going to do is we're going to go ahead and add that here, and we'll add it in the same order that's in the routing table. 1.0. And maybe I'll add via, a little shorthand here, 2.253. And this is via 2.254. Okay, so this is the command. All right, so there we have it. Now let's try a little bit of pinging. So before I could not get to 2.254. Let's see if we can do that now. And we can. All right, outstanding, outstanding. Now, if I now just take the next entry, which is 3.253, theoretically this should work because it's the same router and I have a route for the 3net. So let's try 3.253. And that works. All right, we're going to go for it here. We're going to go for it. I want to get to 3.254. So let's try that. Oh no, this doesn't work. Now if we ask ourselves the question, well, I couldn't get to the 3net before, why didn't that work? And the answer is that the packet was able to go out but not come back. So let's do our simulation here. And we don't actually need the packet type, right? We're just going to go and run it. And off we go. So again, we're looking for the 4net. We're going all the way, oh, I'm sorry, we're going to 3.254. We're going to this address right here. So again, it gets all the way out there. The router 3 knows where the 3 net is. Router 4 knows where the 3 net is. But router 5, oh, it died at router 5. Well, again, looking at this message, it's from 1.1. What doesn't router 5 know about? It doesn't know how to get to the 1 net. So let's help it out. And what we're going to do is an IP route statement here. And we'll add it. I'm going to do an IP route for, again, we're trying to get to the 1 net. IP route 192.168.1.0, a mask. Now, who am I going to send this to? Somebody that's not me, because I don't know how to get there, but somebody that I can touch. 3.253 answers the bill because I know where the 3 net and the 4 net are already. So it's 192.168.3.253. I think we're okay. All right. So that's the entry that I think we ought to use, and so let's put that in there. IP route 192.168.1.0 mask and the forwarding router's IP address right here 3.253 192.168.3 3.253. Let's take a look at our routing table. Let's take a look at our routing table when we spell it correctly. And we see we have a new static route and 2 directly connected routes. By the way, these other routing table entries here, these are /32s. These are just the IP address of the interface. That's what that's identifying. All right, we've added this route. So now we go like this. We say, well, I have a new static route, 192.168.1.0 via 3.253. There we go. Well, let's see if this works now. And look at that. We have success. All right, so we made it all the way to 3.254. Let's try 4.253. Theoretically, this should work because it's the same router. Or will it? Let's find out. Okay, so that the router's other interface is 4.253. Oh no, destination unreachable. But we have a clue here. We have a clue. We have a clue that this came from 1.254. This is actually an ICMP destination unreachable message. This is not just something like this from the host. It says it timed out. Let's actually see what that looks like. So I'm going to run the simulation again, and then I'm going to try the ping again. And here it goes out, right? It goes up to my router, and then my router sends me something back. What is it sending me? Oh my goodness. It sends me back. Look, it's from my router, 1.254, to me. It says, hey, Bubba, this address that you're trying to get to, that is destination unreachable. So this is the original message that I tried to send, but the code that I'm getting back here is a type 3, destination unreachable, host unreachable. So this is an ICMP message from my router telling me that it can't get there. Beautiful tool for troubleshooting. All right, let's go to real time. And so clearly the problem is that the router does not know how to get to the 4 net. And so what we're going to do is we're going to add another route here. And actually, maybe I can copy and paste this. Maybe? No, it's not going to let me. All right. IP route 192.168.4.0, 255.255.255.0. How do we get there? Well, I have all these other routes, so I could use them, but that is multiple passes through the routing table, and that's incorrect. So I'm just going to use somebody that's not me, but somebody that I can touch. And so it's 2.254. 192.168.2.254. So that is what I'm going to do. So back on the router here, we're going to say, we change this to the 4net, and it's still 2.254. So let's take a look at our routing table. And there we have it, a new static route. Now, take a look at these two static routes. They are both pointing to the same IP address as the forwarding router. That might make them a candidate for a default route. Okay, so we're going to add a new entry here. We've got another static entry for 192.168.4.0 via 2.254. All right, see if it works. Oh, look at this. We have another message. A reply from 2.254 that says Destination Unreachable. Oh, so take a look at this. My router knows it, but router number 4 in the middle does not know how to get to the 4net. So now we have to come over here and fix router number 4. And so that's what we're going to do. We're going to add another entry here. We're going to say IP route 192.168.4.0 255.255.255.0. And how do we get there? Well, when we wanted to go to the 1net from the perspective of router 4, we said that the 1net was to the left, or that way, whichever way you're looking at it, right? It's to the left of this router. So we got there via 2.253. Where is the 4net relative to router number 4? Well, it's the opposite direction. So our new forwarding router interface is going to be 3.254. There we have it. So that's our routing table entry. Let's move this over here. Okay. So let's do that. Let's fix that on the router here. We'll do IP route 192.168. Where are we trying to go? 4.0/24. And then 192.168.3, right? This address right here, 3.254. Do a show IP route here. And there we have a new static route. Okay. Now notice that the two static routes that I've entered have forwarding addresses of 2.253 and 3.254. There's nothing in there that indicates that one or the other would be a better default route. So we're going to leave that live for right now. But we also need to update our routing table. When we do it on the router, we'll do it in text here. 192.168.4.0 via 3.254. Okay. I like how this is going. I'm enthusiastic. We've solved some problems. We've decided the right way to do this. Let's try to go to 4.253 again. Hey, look at that, it got there. All right, now one thing that I forgot to do when we were setting this up was I forgot to configure this host. So let's do that. 4.1. Same mask as everybody else. Whoops. That's not the same mask. And we need a gateway. Now, based on my convention, it'll be 2.2 or 4.253. So there we go. Now we'll just do a quick test. Make sure we can hit our gateway. We'll try to ping 192.168.4.253. That works. All right. So we've got connectivity for our host here. And let's go for broke now. Here we go. Ready? We're going to try and go all the way across to 4.1. So we're going to ping 192.168.4.1. Hey, look at that. Look at that. I'm very enthusiastic. It looks like this works. Okay, terrific. So it works all the way across. We're just fine, right? Everything works? Well, no. Take a look here. How many networks do we have? We've got 1, 2, 3, 4 networks. I've got 4 networks here, and I've got 4 networks here. I do not have 4 networks here. I'm missing the 2net. Well, what's the impact of that? Well, if from this host I try to ping anybody on the 2net, ping 192.168.2.253, for example, destination unreachable from 4.253. That's my router telling me that it doesn't know how to get to the destination. So the way that we fix that is with another IP route command. So the IP route command that I would issue here is IP route 192.168.2.0, the mask, and the forwarding router's IP address, which is, in this case, somebody that's not me, but somebody I can touch. So 3.253. Like that. Now if we take a look, I've used the same forwarding router interface, so that might be a candidate for a default route as well. So back into here, we'll add an IP route to the 2net, same forwarding router, show IP route, there we go. Oops, those are my there's my directly connected. There they are, right up there. Whoops. Okay. All right. So we're going to add the 2net. 192.168.2.0 and via 3.253. Okay. Well, let's see if all those machinations actually worked. So same attempt. There we go. Now we have a fully configured topology, and we've done our static routing correctly. We have ignored these nonsensical lines here. Now we might be able to get away with this one. So let's actually see how that might work. So I'm going to go into router number 1, and I'm going to eliminate these 2 routes. So we'll go back to normal here, or back to the default, I should say. Config T, and I'm going to eliminate the entry for the 4net and for the 3net. Let's see if it's the easy way. Let's do it the hard way. I guess this is an easy way. Now, to show you that, nothing up my sleeve, let's take a look at our routing table. Let's try that again. Okay. So we're back to our default, right? 2 directly connected networks. And the impact of this is that we can no longer get to anything outside the 2net. So if I ping 192.168.3.253, I no longer know how to get there. Let's try 4.1. We know 4.1 just worked, right? Let's try 4.1. That's all the way on the other side. And again, this doesn't work. Okay. Now the default route that I might use to eliminate both of these is going to be this one right here, this top one. Can I do that? Well, this top one right here. So it's going to look a little strange in the routing table, but we just get used to looking what a default static route looks like. So let's do that. So IP route, all zeros matches everything, right, because of the ANDing process. So we're going to do 0.0.0.0, 0.0.0.0, 192.168.2.254. somebody that's not me, but somebody that I can talk to. Okay, let's take a look at our routing table. And there it is. So this is all that I need right here because I'm on the end of this network. So let's see if we're back to full connectivity. Remember that the two that didn't work just then were 3.253, and all of a sudden we can get there. Let's try 3.254, and let's go for broke. 4.1. Ta-da! So that all works. We are in business, and what we did was we got our new static route that is default route. You can see here that we've got all zeros in the match criteria. All right, this video is getting a little bit long, so I'm going to cut it right there. Join me again next week when we tackle this thing. Oh my goodness, it's just enormous. The thing about this one is that we've got lots of switches and multi-layer switches, and the networks that are connected are going to have to be interconnected via VLANs. So that's what we're going to do next time. Okay, this has been static routing done the correct way, right? The command that we used all over the place was IP route, then the network, and then the mask of that network, and then the next hop. And remember that the next hop is going to be somebody that's not you, but someone you can reach, meaning somebody that you have a directly connected interface, and you can ARP directly for that node. Well, I hope that this helped out. Thanks a lot for watching. Thanks for listening. Like and subscribe if I helped, and may those packets always reach their destinations, especially if you do your static routing the way you're supposed to.